Sometimes you need to take control of exactly when your MCP client initializes, whether to measure performance, handle errors differently, or coordinate with other setup steps. We'll disable FastMCP's automatic initialization and manually trigger it with a custom timeout, showing how to verify connection's state before and after the handshake. You'll see how to check initialization status, then access server tools only after the explicit handshake completes.
From FastMCP import client. #disable automatic initialization. Client equals client. My MCP server pi. Auto-initialize equals false. Async with client. #connection established, but not initialized yet. Print F connected. Client is connected. Print F initialized. Client initialize result is not none. #false. #initialize manually with custom timeout. Result equals await client. Initialize timeout equals 10, 0. Print F server. Result server info name. #now ready for operations. Tools equals await client list tools.
This demonstrates the explicit initialization pattern with deferred execution control. The code shows how to separate connection establishment from protocol initialization, giving developers precise timing control over when server capabilities are loaded. What makes this distinctive is the ability to inspect connection state before initialization completes, enabling advanced setup or error handling scenarios. The pattern works by decoupling the physical connection from the logical handshake. The context manager handles transport-level connectivity, while initialization becomes an explicit operation that can be deferred, timed, or conditionally executed. This separation follows the principle of progressive enhancement, where basic connectivity is established first, then enriched with protocol-specific features only when needed. This approach matters for systems requiring deterministic behavior or custom initialization sequences. It solves the problem of implicit magic in client-server interactions, where automatic initialization might fail silently or conflict with other setup steps. Use this when you need to measure initialization time, handle partial failures gracefully, or coordinate initialization with other asynchronous operations. The trade-off is slightly more verbose code in exchange for explicit control and better error handling capabilities. Let's break it down.
From FastMCP import client.
Imports the client class from FastMCP, the primary interface for connecting to MCP servers. This handles all low-level communication, authentication, and session management with the server.
#disable automatic initialization. Client equals client. My MCP server pi. Auto-initialize equals false.
This disables FastMCP's default auto-initialization, giving explicit control over when the connection handshake occurs. Critical for scenarios requiring custom timeouts or pre-connection setup, like loading configuration before initialization. The auto-initialize equals false parameter enforces this manual control pattern.
Async with client. Print F connected. Client is connected.
The Async with context manager establishes the connection to the MCP server while guaranteeing proper cleanup when the block exits. This pattern eliminates resource leaks by handling connection teardown automatically, even if an error occurs. The is connected check verifies the connection state before proceeding with initialization.
#initialize manually with custom timeout. Result equals await client. Initialize timeout equals 10, 0. Print F server. Result server info name.
This manually triggers server initialization with a 10-second timeout, overriding the default behavior we disabled earlier. The result object contains server metadata including the name, confirming successful initialization. This pattern gives explicit control over when initialization occurs, critical for custom startup sequences.
Hash now ready for operations. Tools equals await client list tools.
This invokes the first actual operation after initialization. List tools retrieves all available tools from the server, demonstrating the client is now fully operational and ready for business logic. The await pattern here is standard for all FastMCP client operations. Manual initialization pattern. Disabling auto-initialize gives you explicit control over when your FastMCP client establishes its connection and loads server metadata. The initialize method is idempotent, but subsequent calls still respect your custom timeout parameter. This pattern is essential when you need to manage connection timing or handle initialization errors gracefully.
The client that waits to connect has already arrived.